Welcome to another deep dive, everybody. Ready to get our hands dirty with software development again?
Always.
Awesome.
hmm
Today, we're going to be tackling a pretty interesting concept, threads and events. And
Mhm.
specifically, we're going to be looking at whether threads are really such a great idea, you know?
Yeah, they're often presented as like the de facto solution for modern programming.
Right, exactly. But we're going to challenge that assumption a little bit today.
Yeah.
And our deep dive is based on a paper.
A paper from 1995
Oh, wow. Way back.
by John Ousterhout.
Okay.
And if that name rings a bell, it might be because he's the guy who created the TCL scripting language.
Oh, okay, cool.
Yeah, so this paper is called Why Threads Are a Bad Idea, with the parenthetical for most purposes.
Okay, so there's a little caveat there.
Yeah, exactly.
So before we jump into the controversy here, can you kind of set the stage for us? What are threads and events in programming?
Sure. So let's start with threads. Imagine a program as a highway, right?
Okay.
And each lane on that highway is a thread, allowing different parts of the program to run simultaneously.
So multiple things can be happening at the same time.
Right, like cars moving in their separate lanes. And this simultaneous execution, we call it concurrency.
Okay.
And it can potentially speed up program execution.
Gotcha. Makes sense.
But just like on a highway,
Yeah.
you need mechanisms to manage the traffic flow, right? Prevent collisions.
So we don't have a big pile up of code.
Exactly. That's where synchronization comes in.
Okay.
Synchronization tools like locks, they act as safeguards. So only one thread can access shared data at a time.
So it's like traffic signals and lane dividers to
Yeah,
make sure that everything's running smoothly.
exactly.
Okay.
That makes sense.
Yeah, but you can imagine as the number of threads increase, managing all these locks can get really complicated.
Oh, yeah. It sounds like a recipe for disaster if things aren't handled carefully.
Yeah, and that's where this concept of event-driven programming comes in as an alternative. So instead of having multiple threads running concurrently,
Event-driven programming relies on a single thread that responds to specific events. So you can think of it like a single-lane highway, but with strategically placed exits and on-ramps.
oh,
Interesting. Okay. So these events, they trigger designated functions called callbacks.
okay.
And these callbacks handle the specific tasks associated with that event.
So instead of having that constant traffic flow, like in a multi-threaded environment,
Right.
we have more like a controlled entry and exit system.
Exactly.
Okay, that's interesting. So, but, John Ousterhout had some strong opinions about threads. He basically argued that they're just too complex for most programmers to handle effectively. Why did he take that stance?
So he went into the complexities of threads, particularly the challenges of synchronization. He said that forgetting or mismanaging these locks can lead to data corruption.
Which sounds like a big problem.
Yeah, and debugging data corruption is a nightmare, right? It's like finding a needle in a haystack.
So he's starting to make a case here.
Yeah.
It's making sense.
Yeah, and he also highlighted this issue of deadlock.
Deadlock, what's that?
That's when two or more threads are blocked indefinitely because they're waiting for each other to release the resources they need.
Oh, like two cars at an intersection waiting for each other to go.
Exactly, gridlock.
Yeah.
And he argued that, these challenges are particularly pronounced in a single core processor world.
Oh, right, because back then in 1995, that was pretty much all we had.
Yeah.
But he did also acknowledge that there are times when you really need the power of threads, right?
Yeah, he conceded that.
Especially when you really need that CPU concurrency.
Right, like for high-performance computing.
Right, okay.
Or server applications where you absolutely need that raw processing power.
So it's not that he's saying never use threads.
Right.
He's saying you got to be
Be
strategic.
thoughtful, exactly.
Pick the right tool for the job.
Absolutely.
Okay, I'm starting to see his perspective a little bit more now.
Yeah, and actually that principle holds true even today. We have more advanced tools and techniques for managing concurrency, but it's still about choosing the right approach for the right task.
Awesome. Well, let's dive into some of those more modern solutions in the next part of our deep dive.
One thing that really stood out to me from Ousterhout's paper was how he emphasized the trade-offs. That he was saying that, yeah, events offer simplicity,
Okay.
and you avoid all those synchronization headaches.
Right.
But they can also introduce their own challenges.
Oh, really? So events aren't a perfect solution either.
Not quite, no. So one issue is that if an event handler takes a really long time to execute, it can block the entire event loop.
What does that mean for like a regular person using an application?
Okay, imagine you're on a website, right?
Okay.
And you click a button that triggers some complex calculation. If that calculation takes too long, the whole page might freeze until it's done.
Oh, so it's like everything comes to a screeching halt?
Kind of, yeah. It's like our single lane highway, but there's like this one really slow car.
Oh, holding up all the traffic behind it.
Exactly.
Okay, I see, I see.
And another limitation is that events don't inherently provide true CPU concurrency.
Okay, remind me what that means again.
So remember our highway analogy
Yeah.
with multiple lanes for threads?
Yes.
With events, you're essentially stuck in that single lane, even if your computer has multiple processor cores available.
So if you have a task that could really benefit from all of those cores,
Right.
like some really heavy computation, events might not be the most efficient way to go.
Yeah, precisely. And Ousterhout actually recognized these limitations and proposed like a hybrid approach
A hybrid approach. Oh,
where you combine the benefits of threads and events.
okay.
So he suggested using threads for like performance critical kernels,
Okay,
the parts of the program that really need that maximum computational power,
gotcha.
but then you keep the rest of the code event driven.
So kind of like having dedicated express lanes for high-speed traffic,
Yeah.
but then you also have that well-managed system for regular traffic flow.
That's a great analogy. And this hybrid approach, it's actually become pretty influential in modern software development.
Oh, wow, okay.
Like a lot of systems today use a similar model. They combine threads for those tasks that demand true concurrency, but they use event-driven mechanisms for things like handling user interactions,
Okay.
network requests,
Right.
other asynchronous operations.
So even though his paper was written back in 1995, his ideas are still relevant today.
Yeah, it highlights how understanding these fundamental concepts can help us understand how software development has evolved over time.
It's pretty remarkable, actually. And back then, even experienced programmers felt like they were juggling flaming torches when dealing with threads. But now we have new languages, libraries, frameworks, things that kind of make it a little bit easier.
They abstract away a lot of that complexity.
Right, exactly. Like async await. That's
Okay.
one example.
Yeah, async await in languages like JavaScript and C#,
Right.
it's made asynchronous programming much more approachable.
Right.
You can write asynchronous code that looks and feels almost like synchronous code.
And that makes it easier to...
Way easier to reason about it and maintain it.
Gotcha.
So imagine you're ordering food at a restaurant, right?
Okay.
With async await, you can place your order and then go do other things while you wait. You don't have to stand at the counter
Oh, okay.
blocking everyone else.
So the chef can take your order, start working on it, and I can go browse the menu or find a table.
Exactly.
That makes a lot more sense.
It's much smoother, less disruptive, and it's just one example
Right.
of how these modern tools have made concurrency more manageable.
So there's async await. Are there other things like that too?
Yeah, we have other things like Go's routines and channels.
Routines, what are those?
So think of routines as like lightweight threads.
Yep.
They can be created and managed really efficiently.
Okay.
Like having a team of really skilled cooks all working independently in our kitchen analogy.
Okay, I like where this is going.
And then channels provide a way for these routines to communicate and synchronize with each other. So like a well-coordinated system of orders and deliveries between these cooks.
So there's all this complex stuff happening, but it's all happening in a way that's like behind the scenes.
Right.
The user doesn't have to see all this complexity.
Yeah, a symphony of operations, but like seamlessly orchestrated,
Yeah.
all thanks to these routines and channels.
Wow, that's pretty amazing. So Ousterhout's core arguments about the complexities of threads are still relevant,
Yeah.
but things have changed.
The landscape has definitely shifted.
So if he wrote his paper today, do you think it would have the same impact?
That's a really interesting question.
Yeah.
I think his insights about the trade-offs between threads and events, they'd still resonate.
Okay.
The specific challenges might be different now, but that fundamental need to choose the right tool for the job
Right.
and to approach concurrency with care and understanding, that's still as important as ever.
Yeah. I'm realizing that this deep dive is about more than just threads and events.
Yeah.
It's like looking at how software development has evolved,
Absolutely.
how hardware and software work together,
Yeah.
and this like constant drive to find better ways to build complex systems.
You've got it.
It's really fascinating.
Yeah.
But how does all of this relate to our listener who might not be like a hardcore programmer? How can they connect these concepts back to like their own experience with technology?
It's a great question. I think it's about recognizing that concurrency is all around us. When you're browsing the web, using an app, interacting with a cloud service,
Right.
chances are there are threads and events working behind the scenes.
Make it all happen smoothly.
Yeah.
So it's like knowing that your car has a complex engine,
Yeah,
even if you don't know how every part works,
it
it's
is.
still useful to know that it's there.
And it can help you make more informed decisions about the technology you choose, understand the limitations of different systems,
Right.
appreciate all the effort that goes into creating these seamless digital experiences.
So even for someone who's not a programmer,
Yeah.
understanding these concepts can be really valuable.
Yeah, it's about having that curiosity and appreciation for all that complexity under the surface of our digital interactions.
Well said.
Uh,
We've gone on quite the journey today from talking about Ousterhout's arguments to looking at modern concurrency solutions. What are your final thoughts on this deep dive? What are some key takeaways you want to leave our listener with?
it's funny how a paper from almost 30 years ago
I know, right?
can still be so relevant to the core of what we're talking about today.
It really shows you how important these concepts are.
Yeah, we've got all these new tools, new languages, but those core challenges of concurrency, those trade-offs between different approaches,
Yeah,
the need for good design and implementation, it's all still there.
it's like the foundation.
Exactly, the foundation.
So as we wrap up here, any final thoughts on threads and events?
I think the big takeaway is that there's no one right answer when it comes to concurrency. Threads and events, they're both tools.
Yeah.
They both have their pros and cons,
Right.
and a good programmer knows which one to use in a given situation.
So it's not about always going with the newest, shiniest thing.
Right. It's about understanding the basics, looking at what you're trying to do, and then making a smart decision.
It's almost like a life lesson, isn't it?
Yeah, totally.
Question assumptions, be open to new ideas.
Be adaptable.
Exactly.
Yeah.
Especially in a world where technology is changing so fast.
All the time.
So for our listener who wants to dive deeper into this world,
Yeah.
where should they start?
If they're into the practical stuff, they could look into the concurrency stuff their favorite programming language offers.
And good-
Search for things like async await,
Right.
coroutines, futures, promises, all those good things.
Okay.
If you're more conceptual, you could look into concurrency patterns,
Right.
parallel programming, distributed systems, stuff like that.
You can find a lot of information online about all this.
Tons. And even if you're not a programmer, just understanding these concepts at a high level can help you understand how the digital world works.
It's about connecting the dots.
Mhm.
And hey, if you really want to go deep,
Yeah.
you could go back and read Ousterhout's paper,
Why not?
Why Threads Are a Bad Idea.
Yeah.
It's interesting to see how someone challenged the accepted wisdom of the time.
And that's how innovation happens, right?
Exactly.
Questioning things, thinking differently,
And always remembering that the world of software development never stands still.
always evolving.
So always keep learning. Okay, before we go, I want to leave our listener with one last thought.
Okay.
Think about all the tech you use every day.
Yeah.
Your web browser, your phone apps, all those online services.
Right.
How do you think threads and events are working behind the scenes?
Ooh, that's a good one.
It might change how you see all that technology.
It really might.
It's like a whole new layer of understanding.
Yeah, there's so much happening under the surface that we don't even see.
Well, thank you for joining us on this deep dive into threads and events. Hopefully you've learned something new
Absolutely.
and maybe gained a new appreciation for software development.
It's a fascinating world.
Until next time, happy exploring.